literacy and AI, understanding the way things work. Before I begin, just a very short introduction of myself. My name is Beate Kuhl. I'm working for the Federal Office of Languages in Germany, which is the language service of the German Bundeswehr. We have more than 400 translators, revisers, interpreters, and language assistants and terminologists. And we translate a lot of technical documents, orders, letters, medical documents, everything you can think of. We translate 200,000 and more pages a year. 70% in English, but we have 20 languages in-house. I'm responsible for the translation workflow, translation management, knowledge management, process development, and cut training and support. In this presentation, I want to show the interplay of data management, data literacy, and artificial intelligence, and how important it is to know the basics in order to be able to use AI technologies effectively in your daily work, and especially not to trust data. Because in today's world, we are faced with an ever-increasing amount of data. They can be a valuable resource for us to make informed decisions, gain new insights, and drive innovation, but they can also be a source of fake news, and I think you have heard of these things too. At first, I want to give you some definitions what data management, data literacy, and artificial intelligence are. Then we look at them a little deeper, and in the end, I will give you some hints and tips how you can develop yourself to use these things better. So let's begin with some definitions. Data management, data literacy, and artificial intelligence form a dynamic and symbiotic relationship. And now let's take a look what that means. Data management involves the processes of collecting, storing, organizing, and maintaining data to ensure its accuracy, accessibility, and security. And this is the foundation for the effective utilization of data assets. So data management encompasses tasks such as data governance, data quality assessment, data architecture design, and so on. And then data literacy refers to the ability to understand, to interpret, and effectively communicate insights derived from that data. And it empowers you to make informed decisions based on data analysis and interpretation. So data literacy involves not only technical skills, but also critical thinking to assess data sources, to detect biases, and to recognize patterns in these data. And the third one is AI, and AI involves the use of machines to simulate human intelligence at the moment, allowing them to perform tasks that typically require human cognition. So AI technologies, including machine learning, natural language processing, neural networks, they analyze data to uncover patterns, to make predictions, and to automate decisions. And this all is linked together. So these three subjects, data management, data literacy, and AI, they are connected to each other. Here are some examples of such connections. So AI's effectiveness heavily relies on quality data. Data management ensures that AI systems have access to accurate, relevant, and reliable data for training and for their performance. And well-managed data sets are essential for training AI models to provide accurate predictions and insights. The second one is that individuals with data literacy skills can effectively utilize AI tools. Data literate professionals, they can interpret AI-generated insights. They can critically assess their validity, and they can apply them to their decision-making processes. If you do not know how to use AI-generated data, you cannot use them. You conclude the wrong things, you believe in fake news or something like that. AI technologies, on the other hand, they can automate various data management tasks, such as data cleansing, categorization, tagging. Machine learning algorithms, they can identify the data quality issues and suggest improvements. They can enhance the efficiency of data management processes. And the combination of AI's analytical capabilities and data literacy skills allow you to extract deeper insights from complex data sets. So data literate individuals like you hopefully can collaborate with AI systems to discover trends, correlations, and predictive patterns. And even ethical considerations are vital in both AI and data management. So data management ensures that AI systems adhere to ethical guidelines by using diverse, unbiased, and representative data. Data literacy helps to identify potential biases in AI, in the models and the data sets, and they can promote responsible AI deployment. So in essence, there's a synergy between data management, data literacy, and AI, and that creates a powerful loop of data collection, analysis, interpretation, and decision making. So data management is a collection of measures, procedures, and concepts that aim to make data available to optimally support various processes. But the question is, what is data? On one hand, data can be facts, objective events based on measurements or counts, such as the population of a city. But it can also be a subjective perception of real events that require contextual knowledge, for example, nodes. The resulting data is not the same. They can exist in fundamentally different forms, for example, in visual forms such as text or images. Music and sound recordings are also data, even if they are not visible. And moving images and audiovisual formats are included, such as films or videos. These are all data. A data structure is used to organize data. It arranges the data to be stored according to certain criteria and links them together. A well-designed structure provides clarity and availability of the data. Data structures affect not only the arrangement of data, but also all operations on data, such as searching, moving, sorting. So the criteria on which the data structure is based are also important. For your own computer, for example, it is up to you to determine your own organizational structure. You have to think about criteria for creating a data structure. There could be chronological processes, such as timelines. You could structure according to projects or topics. So no matter how you structure your data, a well-organized data has many advantages. It allows you to find files quickly, whether they are old or new. And the files can be tagged, sorted, and searched by various criteria. So think about that if you build a new structure on one of your devices. So nearly every device comes with a file structure set up by the operating system, and you can customize that to your needs. These structures are often modeled on analog filing systems. There are folders and subfolders, and these subfolders can also contain subfolders and so on. And your files are stored in the folders at different levels. This may sound familiar and simple, but believe me, for a lot of people, it is not simple. A digital structure must be created in a way that makes it easy to retrieve data. So a folder structure should meet 3 criteria. It should be clear, it should be understandable and self-explanatory, and it should be possible to find what you're looking for as quickly as possible. The categories you use to create the folder structure depends on the content to be filed. For example, you could use names for personal files or dates for accounting documents, or you can sort by subject, by region, or by file format. It is always important to name the folders and files clearly so that you know at a glance what is stored in them or what the file contains. Avoid cryptic combinations of characters and abbreviations, so no one would understand that. And also meaningless names such as miscellaneous or texts or various documents or something like that. Those say nothing about the contents and make it difficult to retrieve them. And be careful when you're using special characters in file and folder names, as they can cause errors, or sometimes they are not even allowed, depending on the operating system. But data management is not only about structure. It also includes gathering, validating, and using data in a way that is secure, effective, and hopefully efficient. There are different concepts and approaches to data management, but they all have the same elements to consider. These elements include most of the time the data lifecycle management. That means the life of data from the beginning to the end, including confidentiality, integrity, and availability of the data through the whole life cycle of them. But there's also data quality, data privacy, data security, data access, and data governance you have to consider. And another thing is that having access to the data does not automatically grant the reader the knowledge of how to interpret that data or the ability to derive insight. In fact, it can be quite challenging to judge the accuracy or value in that data. And this is where data literacy is involved. Data literacy describes the ability to read data, to work with data, and to communicate about data by putting it in proper context. And this requires a number of individual skills. These come from different disciplines such as mathematics, statistics, or programming, and together they ensure the necessary competence. Depending on the area of applications or depending on the area of your work, individual skills can have different significance and importance. Typical individual skills include the acquisition, the analysis, management, interpretation, presentation, and application of data. So data literacy is the foundation and key skill for the digital transformation. But what is involved in the competent handling of data? What can you do? Because data literacy refers not only to skills in generating data, but also to skills in receiving data. You have to learn, you have to understand what is behind the first glance. So for example, an awareness of removed or added contextual information is required when you code data. So for example, when you summarize data in the form of averages or when you choose a certain form of visualization. And the decoding, so if you look at a visualization or if you look at some diagrams or charts, that requires an awareness of the actual information content of statistics or graphs. And of course, not everyone is in an organization that tries to build a culture of data literacy. Maybe you want to build your own data literacy to further your career or to learn more about the growing ecosystem of data in the professional world. So how can you become data literate? There are 4 things that are important. The first one is you need to know where the data you're working with came from. What is the source? You have to think if it's biased or if it comes with any sort of agenda attached. Make sure that you examine all the data critically and to judge its source. Is the source trustworthy? And then work on understanding the data you see and interact with in your day-to-day life. Do you understand where the data came from? Can you draw conclusions from it? And once you know your data source and understand what it's saying, you can analyze the data, learn about statistical and analytical methodologies, and common analysis used in your field of data study so you can better understand data analysis. And the most important thing, I think, is always learn the basics, learn current trends, and keep up with leading experts in the field. So now we know that data literacy is the ability to read data and work with data and communicate about data by putting it in proper context. This becomes increasingly important in your workplace, for example. And I will show you some basics, how you can gain skills and confidence. The first thing you have to know is that uncertainty is inevitable. You might be thinking that data is about facts and figures, but any statistician will tell you that any given data set is incomplete. That statistics is actually often about explaining levels of uncertainty. This is important, especially for the use of diagrams and infographics. They will likely mask the incompleteness and make statements seem more factual. So you need to understand that data and, when possible, explain what you don't know. So be true to your audience. Due to these uncertainties, collecting data can be a laborious and detailed process. There are several types of data that can be collected, and each is appropriate for different situations. There are quantitative or numerical data, which is based on precise measurements, and often they can be analyzed with statistical methods. They also can be subdivided into discrete data, continuous data, interval data, and ratio data. On the other hand, there are qualitative or categorical data. They are descriptive based on observations that cannot be measured, such as gender or language is spoken. Analysis of this type of data often involves categorization into themes or patterns based on characteristics. And this data can be subdivided in nominal data and ordinal data. This you always have to have in mind when you're looking at statistics. Then you must be aware that the sources of your data matter. Most, if not all, of the main data collection methods you have likely already heard of: surveys, questionnaires, interviews, observations, and experiments. If the data is collected firsthand by a researcher or by yourself, it is considered primary data. Secondary data is data that has been collected and has been made available for others, like the open data you can find in the internet made by governments or other organizations. They are made for others to analyze and share. So chances that you will be using secondary data are the best. So if you use secondary data, here's some quick questions you can ask yourself to make sure the data is high quality. Is the data from a reputable source? Is it open, restricted, or unavailable? Is the data set the right one for the job at hand? And is it aggregated or normalized? So aggregated means, has it been summarized and you can't identify characteristics? Or is it normalized? That means, does it help you to compare numbers by using a common scale, for example, 1 of 2 people or 10 of 20 students, something like that. Another important thing is to keep your data organized. If you're working with a relatively small data set, such as survey responses, you can probably just use a series of spreadsheets. But if you are downloading public data sets like census figures, you may have more in your hands than you need. Some data sets may even need to be cleaned, which means incorrect or duplicates have to be deleted. Sometimes they even need to be reformatted, for example, if numbers are being read as text by analytical software. And then, as you know from Excel, for example, the calculations will be impossible. Then you have to consider that data often call lots of different stories. When you analyze data, you are generally looking for patterns, and these patterns may tell a story about what has happened or what's most common or something else. So most patterns will come down to relationships between 2 or more variables, which are the things that are being counted, measured, or described. For example, people who are on bowling leagues versus people who are on tennis teams, or how people feel about cats versus how people feel about dogs. So for any of these examples, you might discover in the data a variety of patterns. So the point is that data alone doesn't say anything. It's only through analysis that you can begin to uncover any insights. And there may be many to uncover, so it's worth to keep digging and not merely settle for the first aha you stumble upon. Pay attention to outliers and anomalies. These are significantly different data points that can indicate errors in the data or places for further study and analysis. And of course, remember to be aware of your cognitive biases and potential pitfalls when you conduct your analysis. And at last, when you know your story, share it responsibly. So first, what are you hoping to share with others? Are it descriptions of data, such as frequencies or percentages? Will you show distributions of the data, such as ranges or averages? Or will you show comparisons in the data, such as changes over time or correlations between variables? So once you know what you're hoping to share, you can choose a visual that will be best help someone else to understand key takeaways. And the last thing that you have to accept, you don't need to know everything. You don't need to know everything, but you do need to keep learning. And there's a lot to learn. So if you need help prioritizing what to nail first, it's very important to understand how data can be misused to mislead. And if nothing else, make sure you aren't doing that. So make sure you don't mislead your audience if you are presenting something. So one example of the need for data literacy is data visualization. A successful visualization focuses on the essentials and makes it easier to quickly grasp the content and message. So given the variety of visual representations, it's necessary to know what form is appropriate for what content. So the first and obvious option is to use representational images, photographs, painted things, drawn sketches, or assembled like a montage or a collage. Another type of presentation is abstraction, such as models, sketches, illustrations. The third type is visualization of processes or relationships. There you can use flowcharts or maps. And finally, numbers and data series can be visualized using tables, graphs, various types of diagrams, infographics that combine various display formats with text. So as you can see, data management and data literacy are two sides of the same coin. Data management forms the basis for data literacy. Without effective data management, data cannot be used. Data literacy, in turn, is required to understand and optimize data management processes. So now let's take a look at the third thing, the artificial intelligence. What is artificial intelligence? Artificial intelligence, or called AI, is probably the defining technology of the last decade and perhaps also the next. So briefly speaking, artificial intelligence systems can perform tasks commonly associated with human cognitive functions, such as interpreting speech, playing games, identifying patterns. They typically learn how to do so by processing massive amounts of data, looking for patterns to model in their own decision making. In many cases, humans will supervise an AI's learning process, reinforcing good decisions and discouraging bad ones. But some AI systems are designed to learn without supervision. For instance, by playing a video game over and over until they eventually figure out how the rules are and how to win. So since intelligence is tricky to define, AI experts typically distinguish between different kinds of artificial intelligence. There is at first strong AI, which is also known as artificial general intelligence. This is a machine that can solve problems it's never been trained to work on, much like a human can. This is, for example, the kind of AI you see in movies, like the robots from Westworld, or the character Data from Star Trek: The Next Generation. And this type of AI doesn't actually exist yet. The other is called weak AI, sometimes also referred to as narrow AI or specialized AI. It operates within a limited context and is a simulation of human intelligence. Most of the time, it's applied to a narrowly defined problem, like driving a car or transcribing human speech or curating content on a website. It's often focused on performing a single task extremely well. And these machines seem intelligent, but they operate under far more constraints and limitations than even the most basic human intelligence. Examples are Siri, Alexa, Cortana, and other smart assistants, self-driving cars, Google search, chatbots, email spam filters, Netflix recommendations, and so on and so on. But AI can also be categorized in 4 types, beginning with the task-specific intelligent systems in wide use today and progressing to sentient systems which do not yet exist. Type 1 is reactive machines. These AI systems have no memory and they are very task-specific. They are the oldest form of AI systems that have extremely limited capability. These machines do not have memory-based functionality. That means they cannot use previously gained experience to inform their present actions. They don't have the ability to learn. They could only be used for automatically responding to a limited set or combination of inputs. For example, Deep Blue, maybe you remember that, the IBM chess program that bet Garry Kasparov in the 1990s. So Deep Blue can identify pieces on a chessboard and make predictions. But because it has no memory, it cannot use past experience to inform future ones. Type 2 is limited memory. These machines are machines that have the capabilities of purely reactive machines, and they are also capable of learning from historical data to make decisions. So nearly all existing applications that we know at the moment come under this category of AI. All present-day AI systems, such as those using deep learning, are trained by large volumes of training data. And these data are stored in their memory to form a reference model for solving future problems. These 2 types have been and are found in abundance. But the next 2 types of AI exist for now either as a concept or a work in progress. There is the theory of mind concept. Theory of mind AI is the next level of AI systems. It's a psychology term, and when applied to AI, it means that the systems would have the social intelligence to understand emotions. This type of AI will be able to infer human intentions and to predict behavior, which will be a necessary skill for AI systems to become integral members of human teams. And type 4 is self-awareness. And in this category, AI systems have a sense of self, so which give them consciousness. And machines with self-awareness understand their own current state. And this type of AI does not yet exist. This will be the final stage of AI development and is currently only an hypothetical experiment. So the most essential part of AI is the learning. So machine learning is the foundation of how AI systems learn. The data you give machine learning tools help AI create data sets to learn how to make decisions and predictions without being programmed. However, while machine learning allows AI systems to learn from data, they still need algorithms to process that data and to generate meaningful insights. Neural networks are a type of machine learning algorithm that provides the tools to process the information you create based on AI models. These neural networks contain a number of hidden layers through which the data is processed, allowing the machine to go deep in its learning. That means making connections and weighting input for the best results. And deep learning in the middle is a type of neural network with multiple hidden layers, so it can learn more and more complex relationships in the data. Data scientists can optimize those layers using different formats, text, audio, video, and images to improve accuracy. But they also need much more training. So although the terms machine learning and deep learning come up frequently in conversations about AI, they should not be used interchangeably. Deep learning is a form of machine learning, and machine learning is a subfield of artificial intelligence. So now that we know what AI is, you probably want to know how to use it in practice. As you can see, building an AI system requires several steps. The first step is data collection, and that is one of the most critical parts of developing an AI system. It's a process of collecting vast amounts of data to train AI systems. Your training data can be in any format, text, numbers, images, videos. That depends on whether you use structured or unstructured data sets and what you want to do with them. So the next step is data pre-processing. That means you shouldn't just input data as you find it. AI systems need accurate, up-to-date, and relevant information for the best results. Without pre-processing your data, there's no guarantee of that, especially if you have very large amount of data. Noise removal is one essential process. This means you have to find and remove any data that hurts the learning process and fix the formatting of any structured data. Take an AI model being trained to perform financial analysis, for instance. Look through your training data, like stock prices and interest rates, to find any incorrectly formatted values. Include or remove dollar signs, for example. Ensure the decimal is in the right place and remove any other abnormalities. Then model selection is the next step. This is the part of AI development process where you choose the AI model most suited to the current problem. So there are many AI models available out there, including machine learning algorithms, deep neural networks, or hybrid models using various techniques. Which model you will choose depends on several factors, including the amount of data you have. Do you have millions or billions or trillions? How much time do you have for the training? Your total resources, the type of data you have, your total budget. So some models require very expensive hardware. So you have to choose what you need and what you can afford. So the training stage comes when you have pre-processed the data and chosen your model. During this phase, you will split your data into two sets, a training set and a validation set. The training set is what you use to train the model, and the validation set helps you to see how well trained the model is. Your chosen model will then begin reading your data set using mathematical and computational models to look at the data patterns and create an output model to help it make future predictions. The time this takes depends on the amount of training data you have and how large a model you plan to train. The more layers you have, the longer it will take and the more resources you will use. So then comes testing and evaluating the outcomes. You shouldn't just count on your AI model to be in a production state after it finishes training. Depending on the data set's quality and how good a job you did at pre-processing, the final model may not give great results. That could happen. So this is where the separate validation data set you created helps. Your validation data set contains input and expected output. And then you have to look where your training went wrong and retrain. So after the training and evaluation comes model optimization. That is the process you go through to improve an AI model's performance. It can mean fine-tuning or adjusting your model. And those are two different things. So fine-tuning means optimizing the parameters of your model. You can change the neural network's weights or the AI algorithm used to tune the model. Adjusting the model's architecture means adding and removing layers from the neural network to change the connections between the layers and to better capture data complexities. So that's not trivial. But if you have done all that, deployment is the final stage of the model development lifecycle. After you finish training and optimizing your AI model, it's the process of integrating your model into your existing system. Or if you like, if you want to build a new computer program to use your model. This is the point where you can do that. And the last thing is continuous learning. So AI models aren't something you train only one time. You must regularly train your models on new information to continue seeing accurate output. You can do this in a couple of ways. You can fine-tune your base models. You can update AI models through reinforcement learning, human feedback. So you will monitor and grade the feedback of your AI systems. The system then learns what it did wrong and uses that feedback to give better results in the future. But briefly, this means the process has to start all over again and again and again. What I showed you here, these 8 steps, is just a sample process. Not all AI systems are the same, and maybe you need to change this process to account for your unique needs. But there are lots of papers and books showing different processes. So now you know how these 3 subjects, data management, data literacy, and AI, work. You have to enhance your skills because these skills can significantly boost your professional capabilities and open up new opportunities in our data-driven world. Here are some tips what you can do in each of these areas. For data management, start by understanding the core concepts of data management, including data quality, data governance, data security. Familiarize yourself with data modeling techniques and data storage solutions. Learn data management tools like SQL databases, data warehouse solutions. Practice manipulating and transforming data. Implement data quality practices to ensure accuracy, completeness, consistency, and timelines of your data. Learn data quality assessment techniques, data cleansing methods. Implement data security measures to protect sensitive information. Understand how that works. Learn encryption techniques, data breach prevention strategies. And keep up with the latest advancements in data management technologies and practice them. Explore cloud-based data management solutions, big data analytic platforms, and so on and so on. For data literacy, you have to understand the fundamentals of data analysis, including data types, descriptive statistics, and data visualization techniques. Learn how to collect data from various sources, including databases, APIs, and surveys. Learn statistical analysis methods, including hypothesis testing, regression analysis, time series analysis. Practice that. You can use statistical software packages like R or Python for that. Gain proficiency in data visualization tools like Tableau, Power BI, or QLAC Sense. Most of them offer free test versions. Create effective data visualizations to communicate insights clearly and concisely. Develop your data storytelling skills to present data-driven insights in compelling and persuasive manners. Learn to frame narratives and connect your findings maybe to business objectives. For artificial intelligence, try to grasp the core concepts of artificial intelligence, including machine learning, natural language processing, and computer vision. Learn about different AI algorithms and techniques. Master programming language commonly used in AI development, such as Python, R, or Java. Familiarize yourself with programming libraries and frameworks like TensorFlow, PyTorch, or scikit-learn. Explore popular tools and platforms like Google AI, Microsoft Azure AI, Amazon Web Services. And if possible, practice building your own AI models using these tools. A good thing is to engage in real-world AI projects to apply your skills and gain hands-on experience. For example, contribute to open source AI projects or work on personal AI projects. And keep up with the latest developments in AI research and applications. Read AI research papers, attend conferences, follow experts to stay informed. There are so many possibilities, and a lot of them you can get for free. So in the end, we can say data management, data literacy, and AI are three important concepts in the digital world, and they are very closely connected. They are interrelated and complementary. Data management is the basis of data literacy and AI. Without data, AI models cannot be trained. Data literacy is important for understanding and using AI systems, and AI can help manage and analyze data. So you don't need only one of them, you need all of them. So here are some references I can recommend, some books, some websites. But as you know, I hope, is that those sources get old very fast. So a new book today is old tomorrow. And for more specific information, it is very, very important that you look at research papers, in-depth studies, academic databases, Google Scholar, and research platforms like archives and so on. So you have to inform yourself every day. The knowledge of yesterday is old tomorrow. So I hope we have some time for questions. Yes. Just let me take a look into the chat.
I don't think there are any questions in the chat as yet.
Okay.
Just looking. Turn on camera. Okay, well, I think it was very, very information dense. I've got like 4 pages of questions here, and actually notes as well. So thank you very much, Beate. For everyone else, please, now is the time to put your questions here into the chat, and we'll be looking at them. In the meantime, if I may have the first one, please.
Yes.
So I understand that translation and data management are similar in that they are both ways to help people understand something.
Yeah.
So as a translator, I'm not feeling very confident about my profession right now. I'm thinking about possibly transitioning, right? It could be useful in the future. Do you think that the skills typical for a translator would be transferable to data management roles like organization, research, attention to detail, precision, tolerance for IT-induced pain, something like that?
Yes, yes, of course. Um, I see that in my own organization. We have to change completely. The translators have to learn a lot of new things, not only in translation, but in data management, in using all these things and tools. And it's not so difficult for a translator because it's so similar to learn a language, to know everything about a language, and then to transfer that on IT.
Mhm.
I know most translators are afraid of IT and of technology, but
I beg to differ. I'm from the Commission. Now, we started a thing, it's called AI at EC. It's our community for developing AI and tools that are based on AI. It is led by Christian Brashovanu,
mhm,
also from the AI network. And it started and it's headed by DGT, which is the Organization for Translators. It's not the
yeah,
IT department, it's not
yeah,
Digit, it's DGT because the translators were the ones who started with machine translation, with the neural networks, etc. So
yes,
I, th- I would think that we are quite well, you know, positioned for that?
Yes, we are. We are. In my organization, we started using AI, the first organization in this whole Bundeswehr.
Yeah. High five.
Yeah.
So, okay. Now, my second question would be some rookie mistakes that we should avoid if we want to transition.
um, the most the worst mistake is to trust the data.
Oh,
You always have to check, um, to research, to look deeper in it if they are true. So there are so many hints and pitfalls, and where the machine is hiding information or giving you wrong information. So when I researched for this presentation, I used ChatGPT to give me some sources, and they all didn't exist.
that's a very
So
common, yes.
yes, there were books, they exist with wrong authors and editors, or they didn't even exist.
Although
Websites,
they did announce this week on Monday that they've got a new version that should get rid of most of the hallucinations. So I have to see about that.
we'll
Uh,
see.
I had two more questions while we're still waiting, and still people can put their questions into the chat here. Please do. So one would be purely about machine translation. We, of course, use e-translation as our
Mhm.
neural network MT tool, MT engine. But there are others. There is DeepL, there is Google Translate, all these others. When using machine translation, if you were to choose a tool, would you rather choose a tool trained on less, more highly curated data, or on more data, which is less curated?
This is a question we have in our organization at the moment, because we thought it would be a good idea to train different machines for
Mhm,
different subjects, and
mhm.
it completely failed.
Oh, we are doing the same, of course. We have e-translation, which is based on Euramis data
Mm,
mostly, but we started introducing little bits of data from other sources as well, because for us, it led to more fluency.
yeah,
And for example, if I compare e-translation to DeepL, DeepL is better at generic texts that are, like newspaper
yes,
articles or something, while e-translation will beat it if I'm translating a directive or something.
yes, yes.
Same
Um,
experience.
yeah, we tried that with the different
Mhm.
machines, but that didn't work. The output was very, with a lot of mistakes and very, very bad. But then we took all our texts we translated in our organization and trained it, and so it's losing the baseline it has when we bought it, and now it's very good. So we
Okay.
curated data, but not too much. So
Okay. All right. So it's about finding the right measure. I see.
yes, yes, it's a
Okay.
lot of trial and error. So
Then then we will keep trying, of course.
yes,
Now, there's another one. You mentioned data provenance and understanding where your data comes from, understanding the nature of your data.
yeah,
Of course, it's a very big thing now when training the large language models, which are voraciously eating everything that's on the internet, like copyright or no copyright,
hmm,
protected, unprotected, and horrible and not horrible. There was an executive order in the US, I think like a week ago or something. It's a very, very recent from the Biden administration. They've got a problem with the locked Congress. So it's all coming now without political discussion and through executive orders. And they are requiring disclosure of data provenance for AI tools that are supposed to be used by the government, of course. Do you see that as something that's feasible?
hmm, that's a good question. Maybe it's not feasible, but as we began to train our machines, we also would like to know how our machine was pre-trained with what data, so that we can reason where are the mistakes coming from, and why it is translating things like this and like that and not like we want to have it. That was that was hard for us to understand, and we would have liked to know where the data come from. But I know that it wouldn't be possible to do that, because
Okay.
they crawl the internet and
So if I just say the data provenance, the internets, it's
yeah,
like, yeah.
yeah,
Uh, they said, and I saw this wonderful quote that the EU may not be at the forefront of AI development, but it is at the top of AI regulation, which I think is very, very good.
yeah.
So, do you think that we can, maybe catch up, overtake, etc., be better thanks to the regulation? That, for example, by having better data curation in our regulation, that it might lead to more explainable AI, to more reliable AI.
I hope so. I don't know. Maybe the rules are a bit too strict. Um,
Okay.
but on the other hand, it's good to have rules so you can see what happens and you can look back why that happens because you have these rules. So if they aren't too strict, I think it's a good thing.
Okay. Thank you. And possibly, I think there might not be any questions in the end. So, if there are any translators here in the audience who are as like I am unsure about our future and thinking about transition, do you think now is a good time for that? Is it not too late, or is it too soon?
Um,
Is it something you'd recommend?
so what I can recommend is don't hide from these new things. Um, I know some translators who always said, no, I don't want to use computers, I don't want to use cat tools. Of course, I don't want to use MT. And now they can't translate anymore because they don't know anything about tools and things, and they just want to use a typewriter, and they are not able to work in a modern organization with all the state of the art tools and things. So don't think, oh, it will go away tomorrow.
I'm not sure about this. 10 years ago, we had a translator who refused to work on a computer. So the way that he would work is he would read the original and he would directly dictate the translation to an assistant who was typing that on a computer for them. And we're just looking now with Whisper 3, and the new models for speech to text. This is now again becoming possible and feasible, right?
Yes.
so, so maybe we're going back to the beginning. Well,
Yeah,
thank you very much.
yeah, you're welcome. I hope you could take something home
I do.
from.
Let me see here before we about takeaway. You are reminding me of something. There's step two. There's first question. Oh, there's Alisa saying thank you. Let me see here. Uh, there might be a Slido opening now. I asked if it would be open to ask people for their main takeaways from this. Oh, never mind. So there is not a Slido organized. So please, anyone who is here, I hope that you remember your main takeaways so that you can share them with the rest of the audience in the next sessions. Thank
Yeah.
you very much. Have a nice day.
Yeah. Have a nice day and thank you for listening. Bye.
Bye bye.